Okay, we're gonna take a deep dive into ClassRep D. ClassRep. If you say ClassRep, let's say GS. The G segment register points to the current CPU record. So we're on core 0, so the number is 0. We have some flags. So it's a C CPU type. So this is the structure. And what happens is when I say ClassRep D and ClassRep and I type GS, it knows GS is. This is kind of like dynamic programming. It knows GS is class type, C class type, and so it pulls up the record, the structure, it pulls up the structure to dump the record. Now, if you say ClassRep dynamic, then it will let you edit. Now you can see the swap counter is being changed. This is dynamic. You can actually change these values over here. We don't want to crash it. Anyway, now how does it do this, you might be wondering. Well, we have the compiler information on the class. So like, for example, if we say there's a hash function, a hash table type function, that's a function like a C function. If we say TempEF, now if we say hash find, and we say, let's say who is a command, and if we say we have to give it the hash table to search, FS is the current task record, and let's tell it all a mask. Normally we'd say, okay, HTT, hash table type function, hash. Okay, so that we got, looks like we got a 0 value for that. Why did we get a 0 value? I was just doing this. Let's see. Maybe it's not. Okay, it's not 0. Okay, let me explain what just happened. FS is the current task. GS is the current CPU or core. FS is the current task. Each task has a hash table, and the hash table, if it's not found in the hash table, it searches the parent hash table. This is a symbol table. If you want to know, it's a, what do you call it, a map or something like that. Anyway, and then there's different types of entries in the hash table. Hash table type function. So who is a function, and it has parameters fu flags, h, out name. So it has a parameter list. Now, as it turns out, well, okay. Now watch what I'm going to do here. ClassRep. Now there's some magic that happens right here. Okay, ClassRep knows the structure for a hash function. Basically, the type of TempEF is a hash function pointer, and what ClassRep does is it uses this is a new feature of my compiler that makes it kind of dynamic. This is a if you say last class, this is a key word right here. What it's going to do is it's going to replace this value with the text string of the last. I think it's only for pointers. Anyway, the last class, that's the previous argument. I know it sounds kind of weird, but what this allows is for us to have this ClassRep function. So in other words, this is the same as typing, if I say C hash function. I think we don't have to say pointer. I think we just say C hash function. Okay, that should be the same. That's the equivalent, because it we have the symbol table. we can look up the symbol hash function, and now, okay, now we're looking at, okay, well, anyway, so a hash function has the following member variables. String, that's inherent, that's all hash functions have a string. A type, oh, let's see if we can see, there's the string. The string is over here, who, and type, link, index, and then when you have different hash table entry types, you have different member variables towards the bottom. They all inherit the base hash, C hash type. Anyway, now what I'm going to show you is we're going to look at the, okay, so basically for any variable you want, you can, any function, any class or structure, you can use ClassRep, and you can just say, we're going to look at, FS is the current task record. Notice it's static. If we say FS, if we say ClassRep dynamic, now the values change. They're updated every time the screen gets refreshed, which it always refreshes 30 frames a second no matter what. All the time it's refreshing 30 frames a second. So now let's look what we can do here. I'm going to grab with Control grab and move it around, and what I want you to do is watch the scroll X. Okay, watch scroll X. I'm going to grab 10, 20, 18. It's bigger and bigger. You see the scroll X is changing. Okay, and also the anyway, so now let's take a deep dive into ClassRep D. Okay, so Control Shift F1. So ClassRep D, we have that crazy last class thing. Now, what does it do with the last class? It well, anyway, it calls. I think we call this a wrapper function. I don't know what you want to call it. This outputs to a document, and then if it's in the debugger, we don't have a scrolling window. So what we do instead is we do a time delay as we dump the document. So it does line by line kind of slowly so that you can see it if you're in the debugger. I never use the debugger. I don't really ever use this either, but in theory you might want to use ClassRep to debug. You can put it into source code. I use printf debugging pretty much, and anyway I modify the progress. The way I debug is I write values to oh, I can't change it. Anyway, I write values to the progress variables. So ClassRep 2, that's this. Now we're going to get some craziness in order to make that dynamic thing. So what are we doing? First of all, we have to do this recursively, of course, because you can have classes within classes. And anyway, what it does is it goes through the member list of the class type of the record you're dumping. It goes through the member variables. This is using an internal structure that the compiler has. I think we look up in the hash. First of all, we find the class name, and that gives us the class record. Then we go through the member variables of the class, and there's various data types. If it's an internal type, that's pretty much bottom of this depth scan. Once you get to internal type, that's the bottom. Otherwise, you want to recurse, obviously. So if it's not an internal type, we're going to recurse down here, I do believe. It checks to see how deep we are. You can adjust the depth, and then it calls recursively to print itself. So I buffer to a document. That's like a buffer to a document so that when we return, we can go ahead and do it slowly if it's in the debugger. scroll, so slowly printing out. Now, what do we have here? Okay, so basically, if we have a character, a U8 or an I8, then we want to, okay, now we're printing, this is where it gets crazy. These are $doc. We have our $ rich format. Okay, well, these are $docs. This is saying refresh data, and that is not a pointer, and then it does not have a terminator. DA is the data entry or whatever widget. Anyway, this is some crazy stuff. Here's where it gets crazy. You have to tell it the update data. This is to make it read write. I don't know why I didn't make that read write. So if it's I guess we can't read write, I would imagine. Maybe I can change that, or maybe I just missed it. Anyway, so this is saying not only do we want to refresh every 30 frames, we want to capture what was changed for this widget. So that's update data, refresh data, and this is we have a text buffer of 32 characters, and this is calling it the data type R8 or U8. I'm sorry. Boy, I'm confused. Okay. Oh, this is for a byte. This is not a character pointer. This is for a byte. This is for a if the depth is, what is this? If it's one pointer, so if it's U8, if it's not a pointer, it's a character. If it's a pointer, it's a character star is a string. If it's not a pointer, this is how many stars. If I should call that stars. Anyway, and I'm going to change that to stars when we get done. So I guess it is. Maybe it's different here. Anyway, so what I wanted to explain is this data type. You have to set the width, the size of the data entry with this raw. I think that's called raw type. I don't know, internal type, raw type. I don't know which one. Anyway, so that's how that works. And then of course there's the recursion, and it makes a tree so that we can, when we click, we can open up the tree branch, indent, unindent. Anyway, so that's a pretty deep dive. So let's look at we looked at the we got the record for the who, and now let's look at what the compiler has information on. The member list. Okay, this is the member variables of the who function. FUF flags it's just like a structure, the arguments to a function. And then the local variables, as a matter of fact, are in the same linked list. So in the linked list, first you have the arguments to the function, and then you go. So if we went down the next in the chain, it doesn't expand here, but we could go ahead and let's see. Anyway, we can't get it. So that's that.